All right, welcome everybody to our Semester 2 Midterm Study Guide. This video will address numbers 11 through 20. Let's jump right in. So for number 11, it asks us to simplify. And notice that the operation here is division. So when you're dividing two fractions, remember to change it to multiplication. And we're going to multiply by the reciprocal or drop, switch, flip. May be the way that you've heard about this. So the first thing we're going to do is rewrite this. X squared plus 2x minus 3 over x squared plus x minus 6 times, so I'm dropped the first term, I'm switching my sign, and now I'm going to flip 2x squared minus 4x over 6x. So notice that this is what happened. These guys swap places. Okay, and that's because I changed from division to multiplication. Well, now it's time to simplify. And I know that I cannot simplify anything until there are factors that I cancel out. So we have to factor everything. Let's factor the top using magic X. I am getting X. So you should do this work on your own because I'm not going to show the work for how to factor this, but this is the work you should get. So we're going to get x plus 3 and x minus 1. On the right side, I'm doing GCF, and I'm pulling out 2x. I'm left with x minus 2. And in the denominator on the left side, I'm doing magic x again. This one was GCF. So I'm getting x. Two numbers that multiply to negative 6 would be 3 and 2, and the way they'll add up to positive 1 is having a positive on 3 and minus on the 2. And this guy just stays 6x. Okay, now we can cancel common factors. So my x plus 3 on the top and bottom will go. And I have an x minus 2 on the top that'll cancel with x minus 2 on the bottom. And last but not least, notice that because these are being multiplied, the x's can cancel. And so too can the 2 and the 6, leaving us with a 1 on top and a 3 in the denominator. So my final answer here is x minus 1 all over 3. All right, let's jump into the second problem. It's asking us to solve, and this time notice that we're dealing specifically, since x is in the exponent, we're dealing with either an exponential, we're dealing with an exponential equation. And the first thing you want to do with an exponential equation is try to find a common base. So number 1, find a common base between 3 and 50. So for example, 3 and 27 have a common base. That's 3 to the 1, that's 3 cubed. 2 and 16 have a common base. That's 2 to the 1, and that's 2 to the 4th. So the bases, I can rewrite them to be the same. But between 3 and 50, there is no common base because 3 to the nothing is going to give me 50. So if you cannot find a common base, then that means you're stuck. And when you're stuck, you should ask yourself, what form am I in? Well, right now I'm in exponential form. And that means that we're going to have to go to log form to figure this out. So going from exponential to log form involves bringing down the exponent, log, base. Now, which one of these numbers is my base? Well, the guy under the exponent is the base always, so that goes small at the bottom of 50. Next step, we'd like to actually plug this into our calculator, but as you know, our calculators don't do log base 3, so we'll have to use change of base formula. And that will turn into log of 50 divided by log of 3. And now we can plug that into our calculator. So remember, for change of base, the base always goes into the denominator. And then the big number stays in the top. Okay. So I'm plugging this into my calculator, and I'm getting 4x equals log 50 is giving me, oh, whoops, something weird happened. So for log 50, I'm getting 1.69 897, and some more numbers, divided by log 3, I'm getting 0.47712, and some more numbers. When I divide these two, I'm getting 3.56, and in the last step, I'll divide both sides by 4 to solve for x, and for x, I'm getting 0.8902, and that's my final answer. Okay, number 4 says I'm putting $6,000 into a retirement savings at 2.75% compounded annually. Now my friend is putting $5,500 at 3.5% compounded quarterly. And the final question is, how much money do each of you have after 6 years? So everything I highlighted here is important. This represents our principal, the amount that we put in. This represents our interest rate. This represents the number of times we compound per year, which is 1. Our interest rate, moving the decimal over 2 spots, is 0.0275, and our principal here was 6,000. Okay, for the second friend, the principal was 5,500. Oh gosh, I've made a mistake. Okay, bear with me for just a sec. Okay, so for the second friend, the principal was 5,500. The interest rate right here is moving the decimal over 2 spots, 0.035, and compounding quarterly means that n equals 4 times per year. And finally, notice that down here it says how much time do you have after 6 years, so we'll use 6 years as our t for both. So here's our formula that we'll be plugging into. A equals p parentheses 1 plus r over n to the power of nt. Now I'll plug in for the first guy, see how much he has after 6 years. So that's 6,000 is my principal. My rate is 0.0275 divided by n, which is 1, to the power of 1 times t, and t was 6. Okay, so you'll plug that very carefully into your calculator. And then for the second guy, I'll color code him as blue. He's putting in 5,500 as his principal amount. His interest rate 0.035, because remember 3.5%, and divided by n. Instead of n, I should write 4 because it's compounding 4 times per year. It's the power of n times t. And plugging these each into our calculators carefully. Let me see what I'm going to get. So it looks like we come out with 7,000 in red. $60.61, whereas our friend on the right here comes out, and I'm rounding to $6,779.03, and that's how much we each have. Okay, number 14, find the solutions to this equation. So the first thing you want to do when dealing with an equation with fractions, this is called a rational equation. Basically, rational just means it has fractions. Is you want to find the least common denominator and multiply each term by the least common denominator. So let's look here at our denominators. I have x plus 4, x plus 1, and x plus 4, x plus 1. So our least common denominator is going to be x plus 4 and x plus 1. And now I've represented everybody. I've got this guy, everyone's represented down there. So now I'm going to multiply each term. Just so that my work is a little more clear, I'll rewrite the problem. So let's begin. I'm going to multiply each term by the whole least common denominator. X plus 4, x plus 1, x plus 4, and x plus 1. And now as we go across, notice that my new numerator here, which is 2x plus 4x plus 1 over x plus 4, well, we're going to have some cancellations. This x plus 4 cancels with this x plus 4. Now look at the second term. This is my numerator. This is my denominator. So notice what cancels. The x plus 1s. And in the last term with the negative 6, actually both terms will cancel. So now we're left with 2 parentheses x plus 1, because that's what's left from here, plus what we're left from here is x parentheses x plus 4. And from the right side, we're only left with negative 6. So let's finish solving this for x. Distributing, I get 2x plus 2 plus x squared plus 4x equals negative 6. And since I'm dealing with a quadratic, I'll move everything, all of the terms, to the same side and set it equal to 0 so I can factor. So I've got x squared, combining my like terms here, plus 6x. And then I have plus 2 equals negative 6. But I know I need to move that 6 over. So I'm left with x squared plus 6x plus 8 equals 0. Now I need a little more room to finish solving, so I'm going to go to the side because I need to factor. So using magic x or any other method that you know to factor, two numbers that multiply to 8, okay, that multiply to 8 but add up to 6, I know are 4 and 2, and they should both be positive. So I'm getting x equals negative 4 and x equals negative 2. Now, if you circled both of these answers, you'd be making a mistake. So there's one more thing you have to check, and that is check for extraneous solutions. Look at the beginning. Remember, your denominator, you can never ever divide by 0. So if my denominator here is x plus 4, that means x cannot equal negative 4. Because negative 4 plus 4 is 0, and then I'd have division by 0. Based on this denominator, I also know x cannot equal negative 1. Then these guys are just repeating, x can equal negative 4 or negative 1. So notice that actually, since x cannot equal negative 4, this cannot be a solution. Just like x can't equal negative 1. So that means my only true answer here is x equals negative 2. Okay, because x equals negative 4 was extraneous. All right, chugging right along. So Stephanie made a mistake here. In which step is her error? So right away, look at the first step. We're solving a radical equation. That means to undo a square root, we square both sides, or basically we take it to the power of 2 on both sides. So that's pretty much what she did. She said to undo that square root there, I'm going to square both sides. And that's why on the right side, she ended up with 64, because 8 squared. And then here, the square root canceled with the square and gave me just x minus 1. But the problem is that she forgot to square the number in front, this 4. The 4 also should be squared because it's the entire side that gets squared. So that means on the left side, instead of being 4 here, it should have been a 16. And so that's the mistake she made. So for example, if I have 3 square root x minus 2 equals 10, and I want to square both sides, I should get 3 squared is 9. Square root of x minus 2 squared is just x minus 2. That canceled with this. And on the right side, I would get 100. So watch out for that on your final, on your midterm. All right, number 16. we're solving again, another exponential. And notice between 10 and 50, as before, there is no common base. Because 10 and 50, it's not like I can rewrite 50 as 10 to the 5 or anything like that. Because that's actually 10 times 10 times 10, which is, right, that's not 50. So since I can't get a common base between 10 and 5, I know I'm going to have to go into log form. So go into log form. We always bring down the exponent first, so I'll get 3x equals. And from left to right, my base is 10, 50. Now my calculator can actually do log base 10 of 50. So all I have to do, because remember log base 10 is the same as just regular old log. So we'll plug that into our calculator. For people with iPhones, you hit 50 first, then log. And I'm getting that to equal 1.69897 and a bunch of other numbers. I'll divide both sides by 3 to get 0.5663. All right, number 17. What's the remainder when we're dividing by x plus 1? So there are different ways you can divide, and in this case, I'm going to use synthetic division. So to solve using synthetic division, we need a number in a box and then a bunch of coefficients. Well, the number in the box is found by setting this guy equal to 0 and solving for x. Let me make some room. Solving for x, I get x equals -1, and that's the number that goes in my box. Next, for my coefficients.
Sorry, I'm not sure.
Okay, that was my echo. That was really weird. Okay, next, the numbers that go in the box are the coefficients here. So the -1 in front, the +4, the -5, and the -5 in order. So we'll bring down the first term, -1, multiply across. -1 times -1 is +1, and we add down. So let me make a note. We add down, but we multiply across into the box. So I'm adding down now. 4 plus 1 is 5, and now I'll multiply across into my box. 5 times -1 is -5. Adding down, these two become -10. Multiplying across, I get +10. Adding down, I get +5. And remember, that number that's at the very end is our remainder. So here, our answer is we have a remainder of 5. All right, number 18, solve using the properties of logarithms. So step 1, any numbers in front, here there is no number in front, becomes an exponent. Step 2, we will condense our logs. So right now I have 2 logs on the left, but I need just 1 log. So we'll write log base 4 of. And see if you remember this from your previous lessons, which is if there's a positive in front of that log, then the term is in the numerator. In the second term, though, I have a negative out in front. This negative means that my 5 is going to go into my denominator. And the rest of this is the same, equals 2. So now to solve my log equation, I'm going to go from log form to exponential form. We do that by starting at the base. 4 to the power of 2 equals x squared over 5. Now I'm just going to solve for x. So I get 16 equals x squared over 5. I'll multiply both sides by 5 to get x squared equals 16 times 5 is 80. And then the last step, I'll take the square root of both sides, getting x equals plus or minus the square root of 80. And the square root of 80 can actually be simplified. So simplify that whatever way you know best. But what I'm seeing is that I have a pair of 2's, so that will come out as 2. Another pair of 2's will come out as 2. and this leftover 5 will stay on the inside. So that means x equals plus or minus 4 square root 5. Now, really quick, the reason why I only have one answer here, in your answers, you'll notice that the answer is just positive 4 square root 5. And remember, that's because you can never, ever, ever take log of a negative number. And if I had negative 4 root 5, that would be taking log of a negative, which we know does not exist. So we only have one answer here. Okay, number 19 says sketch a graph. So to sketch this graph, I'll start on the rightmost. I'll first find, number 1, my x-intercepts. So I can see here that I have 1, 2, 3, 1 for each x-intercepts at x equals 0, x equals positive 3, and x equals negative 1. I get that by setting this equal to 0. So I'm going to draw them in. And x equals negative 1. Okay, now, using the sign in front, that negative in front tells me that I need to start on the right side. My graph is going to be negative, aka my graph is below the axis, negative. Now, at x equals 3, look at the exponent on x equals 3. That exponent is odd. And odd exponents, you're going to flip your sign or you're going to cross the axis. Whereas even exponents means you're going to keep the sign or bounce on the axis. Well, right now I have at x equals 3 an odd power, meaning that my sign is going to flip in that my graph should cross into positive. Now I know I'm going to come back to x equals 0 because there's an intercept there, and I'll look at my new exponent. It's 2. That's even. That means that at this point I'm going to keep the sign, so it was positive, it'll stay positive, or that I will bounce, boop, and not cross. Now I need to go to negative 1 and do this one more time. So at x equals negative 1, our exponent is also odd, meaning I will cross and flip this sign, meaning I went from positive or above the axis to negative or below the axis. And this would be my sketch. Last problem says simplify. So to simplify this, notice that since there's no sign in the middle, there's no like subtraction or addition, that means I'm actually just multiplying. So we will multiply this out by distributing. So I'm going to get x times 2x squared gives me 2x cubed. X times negative x gives me negative x squared. Then I have positive 2x. Next, I'll distribute the second term. Positive 7 times 2x squared gives me plus 14x squared. Notice how I lined my x squareds up because I know they're going to be like terms. 7 times negative x is negative 7x, and 7 times positive 2 is plus 14. So I'm just going to combine my like terms now, and I know I'll have 2x cubed, and this is negative 1 plus 14 gives me plus 13x squared. 2 minus 7 gives me negative 5x plus 14. And we're done. So hopefully that lesson was helpful. And I do hope that you do well on your midterm. I'll see you later.